Hello everybody, my name is Leonardo. I am a professor at the Federal University of Rio Grande, and this presentation is about an evaluation of sharpening filters applied to magnified images. Image magnification is an improvement in the resolution of an image, which allows one to obtain a higher resolution image from a low resolution one. There are many types of magnification methods. They can be classified into reconstruction methods, learning-based methods, and interpolation methods. Next, we talk about some interpolation methods for image magnification. There are many types of interpolation methods for image magnification, from the simple polynomial methods to others which are a bit more complex. Most of the interpolation methods have in common that the methods generate a bit of blur as a byproduct. This issue should be relatively easy to solve. One could apply sharpening filters, which is our next topic. Also, as you can see, there are many options in the literature, which leaves us with a question. Why should we propose a sharpening filter specific for magnified images? Now we present this filter and try to answer this question. The best neighbor filter was recently proposed by us. It takes a low resolution image S and an image R, which results from the application of an interpolation algorithm applied to S. The filter mixes information from both the original image S and the interpolated image R, replacing each pixel in R by its so-called best neighbor, which comes from the original low-resolution image S. Best neighbor is a nearby pixel from the original image, which is the most similar to the corresponding interpolated pixel. The filtered image can be combined to the interpolated image by using this linear combination. The parameter beta controls the strength of the sharpened image in the final result. Now we show how the filter works. On the left, you can see the original image S. This is the nearest neighbor interpolation from S. Above you can see a cubic interpolation from S. We call the image R. A pixel at any position in the image above will be replaced by a pixel from the corresponding nearby positions in the image below. This results in the filtered image as you can see on the right. Now we show another example of the application of the filter. In this example, you can see above the result from cubic interpolation using 4 magnification factors. Below, you can see the result from the filter for each respective image. As you can see, the filter is able to maintain very sharp edges between objects, even with increased magnification factor. Now we move to the experiments, where the filter is evaluated and compared to other sharpening filters from the literature. The sharpening filters are applied on top of 4 interpolation algorithms. Each image is always downscaled and then magnified by interpolation. The quality of the interpolated image is measured using both SNR and structural similarity. Besides BNF, 2 other filters from the literature are used, which are Laplace and LUM. 4 magnification factors were adopted. A small filter window is used for BNF and also LUM, the same filter window, which is set as a function of the magnification factor F. The parameters for the filters, beta for BNF and L for LUM, are computed by the maximization of the quality metric for each image. And the comparison is performed by statistical evaluations using the Wilcoxon sign and rank test. We use 2 image sets from the literature. The first is Morgfile 25 and also BSD 500. Now we show the results. As you can see, on top of the bicubic algorithm, our filter achieved statistically significant improvements in the quality of the images for all magnification factors, for both SNR and structural similarity for both image sets. Now, considering other sharpening filters and on top of other interpolation methods for the Morgfile 25 set, as you can see, the lump filter and BNF were both able to increase the average PSNR for this set, except for the INDI algorithm, where only the BNF filter was able to achieve statistically significant improvements. Now, for the same image set and the same interpolation algorithms, you can see that the lump filter was only able to achieve significant improvements for the images from ICBI, not from the other interpolation algorithms. BNF was able to improve the image from all the interpolation algorithms used, NDI, INDI, and ICBI. Now we show the effect of the filter for a small portion of an image from the Morgfile 25 set. This is the ground truth image. This is a downscale version of the same image. Now the result from the ICBI algorithm, you can see it's not a bad result at all, but there is some blur at some parts of the image. Now the result from BNF, you can see that blur is very much reduced. It is a very sharp image, as you can see. Now the result from the lump filter, also a very sharp image. And finally, the result from the Laplace filter. Now we move to the conclusions. BNF was able to improve the quality of images resulting from interpolation. In further work, we should consider other image sets and state-of-the-art base super resolution algorithms, and also a wider range of sharpening filters to be considered for the comparison. And that's it. Thank you very much. It was a pleasure to be with you. Bye-bye.